This is still under module 1, lesson 1, force. So in its simplest definition, force from your elementary and high school, this is just simply push and pull. So if you push or pull something, you exert this quantity, which is force. And then force also in your higher na nga mga higher level na, like senior high school or junior high school or even college, this is the product of your mass and acceleration. So therefore pala, ang kanang atong ipang push o ipang pull dira, syempre natay mass niana, then since imo na siya gitod, of course it will move. Kapag na movement, of course you have an acceleration. Now force also is a vector quantity. Why? Because if you push or pull something, na kay direction syempre. Like kunyari, you push the wall, you push this wall to the right, so therefore you have a force to the right. And then you also push the wall to the left, of course you have force to the left. So therefore ang force nato is a vector quantity. It has both magnitude and direction. Another thing, bisag nagbarog ra ka sa yuta, of course nakay forces nga imong gi-exert sa yuta, which is your weight. So ang weight dire, since directed siya towards the earth's center, therefore this is a vector quantity, kay naman siya direction. Of course di man pud palupig ang ground by Newton's third law, kay kung dili mo pugong ang ground nimo, may di mabasot ka. So mabasot ka, mangadto ka sa masink ka, mangadto ka sa center of the earth. So therefore na ginay reaction ang imong gitumban, kay natong gitumban diri sa asa ta magtunog. So therefore na siya reaction which is equal to your weight, which is the normal force. So therefore ang ato palang force is not only magnitude but also direction. So since we already through with the definition of force, so let's try to familiarize kung unsay mga klase sa force. Kay daghan jud ning klase sa force. Some are related but some are not. So the first one, pinaka-elementary nga example or type sa force is the applied force. Kapag sinasabing applied force, these are the external entities that causes this force. So external entities ni siya. Some ng external entities nga naka-contribute. Of course, kita, tao, humans. Another one, machine. Okay, let's say, ang tao, imo kay ibirahon ning box. Therefore, you exert an pulling force. And that pulling force is an applied force. Kaya ikaw na siya. And not only humans, let's say na ay damtak are. O damtak na truck. Then nagguroy siya og let's say jeep jeep. So therefore nag-exert siya og applied force sa jeep para maguro niya. Therefore this one is a vehicle, a machine. So not only humans but also a machine or anything that will cause a certain object to change its position or to alter its state. So mana siya mga applied force, kanang nagdukdok ka og lansang, nagdukdok ka, like gisipa nimo ako sa katawo, gisumbag nimo. So therefore mo na ang mga applied force. Now the second example here is action and reaction force. This action and reaction force follows the third law of Newton or third law of motion. So here action force is just the same as applied force. So mana ang imong force nga imong gibuhian. So force. And then unsa ning reaction force? This reaction force is the same magnitude again. This reaction force has same magnitude sa imong applied force or your action force, but opposite direction. Kasi diba sa third law of motion is for every action there is an equal same magnitude and opposite reaction, so opposite direction. Ug unsa may pinaka simplest nga example niini, again kadtong nagbarog ka sa ground, Unsa may galitong force nga imong gi-apply sa ground, of course your weight. This is your action force. Sa FAC, this is your action force. Of course, para mo balance ka sa ground, para makatayo ka, di ka mabasot, na ginay gitawag nga reaction force. So FR, and in other words, this is also called as the normal force. So reaction force. Bisan magkuan ka, let's say you have here a wall, then nakay hook ay dira, magbira ka sa string, nagpull ka, you have an applied force, pulling force. Of course, para di ni matanggal ni siyang hook ay, para kamong duha is in its static equilibrium, di po ni palupig. Therefore, mo-exert po siya equal force para di siya madana po siya gitawag nga reaction force. So again, same ang ilang magnitude but opposite in direction. So take note class, action and reaction force. Your action force is your applied force and your reaction force is the same force, the same magnitude but opposite siya sa imong action force para ma-counteract siya. Para walay mausab sa inyo, same ra mo, you are in a state of static equilibrium. And how about for normal force? So I think from our discussion in the angle of banking, we already discussed this, that the normal force is a force acting perpendicular to the surface. So perpendicular to the surface. Mara jud niya tiga mga class to the surface. Let's say ang imong object kay nagrest sa horizontal plane na kay weight. So imong normal force ani class, actually normal force and reaction force class is somewhat related but not in all cases or in all conditions. So here we have a reaction force which is also equal to the normal force. Both the reaction force and the normal force here are the same. Kaya ang normal force class perpendicular diri sa perpendicular ani nga surface. And they are the same with the reaction force. However, on our second figure, let's say naka-incline na ang object at an angle theta, still our weight is directed downwards but our reaction force is of course upward gyapon siya class. Na siya resultant diri. But our normal force here is naka perpendicular na siya. So meaning naka-inclined na siya with the vertical kaya naka-inclined mo pud ang imong surface diri. So take note class, kung unsa pa nang orientation ng imong surface class, perpendicular gid ang normal force dira. Bisan pag nakaingana na dira class, kana gihapon mo gyud direction sa imong normal force. Bisag nakaingana pa na, mo gihapon ang direction sa imong normal force. Always perpendicular to the surface where your object rests. And the next, the frictional force. So these are resisting force. Resisting force. Kapag sinasabing resisting force, so these are force. So these are forces that counteracts your applied force. Let's say you have here an object. Imo siyang gibira. You have a pulling force. Since meron naman dyan na ikuan, garang ganto dire, nya na ginay friction ng imong box o gang road, therefore na ay resisting force na ay counteract sa imong FA mo nang lisod kay birahon ang box compared sa box nga nailigid. Kay diri sa box nga nailigid, mas konti ang imong resisting na mga agents. So in this case, natay gitawag nga frictional force FF. Same po dire FF, but here mas medyo gamay ang effect sa imong frictional force kay naka-roller man ka or naka-ligid man ka. So again class, take note, resisting force and a force opposite. Again ha, opposite sa imo applied force. Or kung magdagan po ni siya class, this is also a force opposite to the direction of motion. So maginay buhat ra gid sa friction class, magsamok na siya kay siya gay magpapugong nimo para mahunong ka. Mao gali nang mag-throw ta og bola, magpadagan ta, if dili ta mo tamak sa acceleration, from time to time class mohunong gid ang sakyanan tungod sa friction force. Daghay friction sa kalibutan, mo na magpa-stop sa ato object. Again, this is a resisting force and also a force opposite to the applied force. So opposite ni siya. Next, let's jump to other types. We also have here compressive force. This is a type of applied force that is kanang applied siya class on a surface. So perpendicular yang ang pag-apply nila sa that will tend to make the material shorter. So imo siyang gi-press. Na imo siyang gi-shorten ang usa ka material. Let's say we have here a cylindrical rod. Apply kada of force downward. So F compressive. So meaning kung enough imong force, mugamay imong kuan. Mugamay imong cylindrical rod. Mao na. Tungod kay imo siyang gi-compress. So when compressive force, you make a certain object shorten, and always remember that this force acts perpendicular to this surface. So let's say mo na siya ang surface where your force acts, always perpendicular gud ang iyahang force. And the same thing with the tensile force. Compressive force and tensile force they are the same but opposite in direction. Kay ang tensile force, it will cause the object to stretch. So much stretch siya. So imo siya i-pull. Here shorten, you push. So imo siya itod. So tensile, imo stretch, imo i-pull. So we have here FT, and also the other one is FT. So again, this force still acts perpendicular to your surface. Perpendicular gihapon class. Then this is still an applied force, and then it will cause your object to lengthen. So mo taas siya, mo haba siya. So again, compressive, mo short siya, mo push ka. Sa tensile kay imo stretch, and this is not only applicable to cylindrical rod, pwede pod sa mga strings, sa mga wires. Imo siya birahon, you already exert a tensile force or a tension. Then shear force class. Shear force, although kani silang tulo, compressive, tensile, and shear force is mag-usay gini sila, especially sa strength of materials na subject. But shear force is it acts on a different plane or on a different direction. Why? Ang shear force is you cut the object. Cut, imo i-shear or imo i-punch. Let's say maggisi kag papel, shear force na siya. Kung ato ni apply sa mga materials or sa mga machine elements, let's say natay block dere. So na block, then mag-subject kag force ara. Force pud sa kabila. So shear force na siya. Meaning kani siya nga line class sa middle, mo na siya dira ang breaking point, magisi siya. So maingani siya ning resulta after you applied the shear force. So magisi meaning nagisi gid siya, like dislocate siya sa iyang original position, and that surface where this force acts is mo na siya atong surface of interest. And as you can see class, or as you've noticed, ang atong force class, ang atong shear force is not acting perpendicular sa atong surface. So nahimo na siya og ni-act na siya parallel. So therefore for shear force class, it acts parallel parallel. So unlike compressive and tensile that they both act perpendicular, sa shear force it acts parallel. And then the other one class is field force. These are forces that exerted by our magnets, so mga magnetic na mga materials. So magnetic materials. And what are these magnetic materials? We have permanent magnet. Sa permanent magnet, so moto siya na siya magnetic field nga induce para i-attract niya katong mga magnetic materials like iron filings. So ma-attract diba ang mga iron filings because of this field force sa nga gi-induce sa atong magnets. How about electromagnetic force? This electromagnetic force is a combination of electricity. So remember class, in your high school siguro or senior high, di ba, if you have a coil here, then imo siyang agian of current. If you pass a certain current, di ba, magnetize ni siya. So So mga electromagnet kay combination from electricity to magnetism iyan i-convert. Then once mamagnetize na nimong coil ang mga iron filings or mga magnetic materials, mga metals, mo attract na ni sa imong coil. So therefore nasa kay gi-induce nga force para ma-attract ni siyang iron filing. So that comes from the electromagnetic na kanang phenomenon sa atong coil. And then the last force is the nuclear force. These force are what binds the electrons and protons. So electron and proton. So diba sa atong mga atoms nagina siya forces nga nag-separate nilang dalawa or nag-bind nila, diba? Ang sa nucleus naraman jud ang mag-usra mo yun kay ang protons ug neutrons, diba? Protons and neutrons niya nag-revolve raman ang electrons. So kaning protons and neutrons nag-stick gid sila, so therefore na sila forces nga why it sticks together, and then napoy forces nga nag-exist between electrons nga diba ang electrons nga naglibot-libot ra na sa atong protons ug neutrons, libot-libot na sa gawas, still nagyapon na siya kuan dira, na siya orbit dira, na siya constant orbit nga mag-rotate siya sa center of the nucleus, which is composed of protons and neutrons. So nagyapon na siya forces nga that keeps him on its orbit. So that keeps it on its orbit. So mo siya gitawag ng mga nuclear forces or nuclear forces ang tawag ani. That exists between tiny particles, electrons, protons, and neutrons. So since we are already through with the types of forces, let's go to the important laws of motion. So these laws are discovered by Sir Isaac Newton. So ang pinakauna nga law, I think nakuan po ni Galileo Galilei, the law of inertia. So this law, it states that if a body at rest, so let's say if you're at rest, you remain at rest. But if you are in motion, so you still remain in motion, but naa siya'y condition unless acted by external force. So acted by external force. On this first law, we can say nga kung nag-steady ra ka class, steady ra gyud ka. Kung walay mga outside or mga external factors nga mi-induce nimo or mi labot nimo, you will remain steady. But it doesn't mean class nga stationary ka class, wala na force nga nag-act nimo. Of course, there is still force that acts you, but the summation of all that forces class will be zero. Okay, para di ka mo move. Let's say naman gyud kay force nga padung downward, pero kay counteract man gud sa ground, maunang wala ra, di ka mahug, di ka matumba nga. And then let's say gibira po ka sa imong classmate dire, let's say this is an applied force on the right, gibira po ka 5 newtons nya nampoy usa ni mo classmate gibira po sa left, padung sa left o FAL og 5 newtons po. So therefore makancel gyapon, you still remain on that position class kung birahon ka ni ana. So therefore you are still on a state of at rest. So manaog yun ninyo nga dili tanan nga kuan nga mga objects nga nagstay at rest wala na force nga nag-apply nila, naagyapoy force class, but ang summation sa kana nga mga forces would equal to zero, like equal lang ba when move. Pero class kung naa na gay na siya, if kani siyang FAR class mo dako na gay ni, kung birahon ka sa mong classmate diri 10 newtons niya, sa mong classmate sa PCAS 5 newtons lang, therefore mo-move na ka, mo nag-state diri nga unless acted by external force. So na naka external force, nanay na sobra. So kung nanay na sobra, mo-move na gid ka ana. And also for the static or the resting state, we can call this as the static condition. And then recall class, for static condition, para dili ka mag-move, dapat the summation of forces on the vertical must be zero, and also the summation of forces on the horizontal must be also equal to zero. So this is a two-dimensional representation, or the summation of forces at any direction. So any direction must be equal to 0. Tanan, any direction 0. And I think not only for the forces, you also have summation of moments, but let's talk that one later na lang. And for state that you are in motion, so naglihok na ka, so you're moving here. Bisag naglihok ka, class, di gyapon giingon nyo wala na forces nga nag-act nimo. Of course sa imong pag-move na gyud kay forces nga nag-act. Kung ang kana nga forces kay equal ra, na balance ra tanan, therefore you are in a state of dynamic equilibrium. So here, class, static equilibrium. Diri pod natay gitawag nga dynamic equilibrium. So, equilibrium. Then for a dynamic equilibrium, siyempre, summation of all forces at any direction per class must be equal to 0. If ever na sobra, class, therefore, na nakikitawag nga net force. So you now have F net. So if ang imong net force class is nasa value, kung nasa value, class, therefore mo accelerate na ka. Mo ginauban kung gusto ka pakusog dagan, mo accelerate ka. Kung na naka-acceleration class, you are not in the state of dynamic equilibrium. Kay nag-change naman imong velocity. Therefore, the class, for a dynamic equilibrium class, from your kinematics, your velocity must be constant. So, ana ha? Body in motion stays in motion unless acted by external force. Let's say na force nga mabangka ka. So, kung mabangka ka, therefore, ma-stop jud ka. So, ma-stop yung motion. And then, for the first law, also class, the state diri nga, the law of inertia. So, nga nang inertia man gititle ari? Because, ang inertia class, this is the tendency of an object to stay in motion or stay at rest. And then we can experience this one, class, kung magsakay ta og kuan, sakay ta og kanang mga bus, diba? If mudagan ang bus, ang imong ma-feel kay mura kag birahon pa kuan pabalik. Kay ano man, kay ang imong state ana, class, is nagkunong pagod ka. Nya larga day ang bus, since dili mo connected sa bus, therefore napakay tendency nga mo rest pa, like di pa ka ready nga mo move. So therefore mura kag birahon pabalik. The same thing pod, class, ay mo ma-feel if nagdagan ang bus nga imong gisakyan, then muhunog kalit. So pag hunog kalit, class, mura jud kag malabay pa forward, so you'll be overthrown forward. Ngano man, because ang imong body na ay tendency nga mo move siya, always moving. Since na may interruption, class, hing break ang bus, so therefore imong tendency ato nga mo move ka, maunang malabay ka, mura kag malabay pa forward. Kay mo na experience nimo ang gitawag nga inertia. So na-get sa class? Still following? So naka-follow na tanan? Okay. So the second law is the law of acceleration. So here it states that your acceleration, class, is directly proportional to your force, but inversely proportional to your mass. So A is equal to the net force all over mass. So di ba, class, nganong gitawag man siya F net? Of course, kung naay net force, meaning naay ni sobra sa force nga imong gi-act sa imong body, therefore mo accelerate ka. Kay kung imong net force is 0, class, wala kay acceleration, so constant ra imong velocity. Here, since na net force, so meaning you accelerate, and acceleration also, class, is inversely proportional with our mass. Ato ni siya ma-experience sa mga tao nga mga dagko, di ba? Kung massive kay ka nga tao, maglisod kag lihok, lisod kag dagan, because if this goes bigger, if the value of your mass grows bigger, therefore your acceleration will go lower. So gamay mo acceleration man ang hinay ka modagan. Hinay ka modagan, pero gaan di ka sa mga niwang paspas kay modagan. But not all the time given man na siya nga constant imong net force. Pero napoy mga niwang nga hinay modagan ganaman. Siguro kay kanang ko siguro kuha og resistensya. So ang ilang force nga gi-exert sa ilahang tiil medyo hinay. So therefore it depends gid class. Ako atong gi-assume class nga ang mga niwang kusog modagan kay gaan sila given nga kusog pod sila net force. Kusog ang ilahang buhilo sa ilahang tiil. Pero kanang mga way kaon siguro hinay gyapon sila modagan, hinay gyapon ang acceleration kay mag-agad man sa net force nimo. But let's just assume nga constant ang net force between sa kanang dako nga tao, so bugat nga tao,
Good morning.
ug sa niwa nga tao. Yan na. So sa bugat nga tao hinay gani iya acceleration diri class. Hinay gyud sa lesser than the acceleration sa niwang, kay ang niwang class gamay kay siya mass, whereas sa tambok dako kay siya mass. So ngayon siya class. And I think ma-observe din nato sa class sa mga boksingero. So mo ganang mga boksingero class agile gina sila kay nagpa-lose weight man na, pa-lose weight ka, then kusog pa jud kag kumo, gaan kay ka, kusog kay na acceleration mo kumo mutama kay nabang sakita tungod aning law of acceleration. And then another thing pod sa acceleration class, let's say this is your object, this is your object class. So let's say na force nga to class, na force on the right side, na po force on the left side. So kung ato ni apply ang principles acceleration class, if the force that is applied on the right side is greater than the force applied on the left side, therefore you have net force. Sir, asang direction sa tong net force ani sir? Of course class, the direction of the net force is towards the force that is bigger than the rest. So since dako man ang imong force sa right, therefore ngadto imong net force class. Of course ngadto ka mo lisod bugay balik ka mas gamay ni din pikas, therefore ngadto yun ka. So remember class that the direction of your net force will follow the direction of the bigger force sa imong object, or the direction of your net force is also the direction of your motion. Direction of your motion. So sa class, the direction of your net force is the direction of your motion. That's the second law of acceleration. And for the third law class, the third law is medyo kuno siya common na ni siya, since ang third law nag-state that for every action there is an equal and opposite reaction. So ma-apply po rin nato class sa atong real life, kana magtapon kag basura mo balik gid nato mother nature. But in physics, kaning law of interaction ma-apply ni nato sa tanan. Kay let's say if you're just standing on the ground, so gibalik na gid nako no, kung ma-exert ka weight sa ground, of course ang ground pud nimo para di ka mahatak, para ma-stabilize ka, ma-exert pa siyang equal force but opposite in direction. That's why gi-state there is an equal but opposite direction. So we have here the normal force. Kung nagkuhan pud mo kana tong airplane, so kani medyo example tag airplane nga complicated kaayo. Airplane class is complicated ang distribution siyang force ari, because of course why this plane moves horizontally, because of the thrust force. So thrust force class, para maka-move siya class, of course i-equalize pa na siya sa gitawag na drag force. So diba naa siya equal but opposite. So unsa may atong applied force ari, thrust force, kay himove man siya, unsa may counteract niya, drag force, kanang resistance sa air. So man siyang equal but opposite in direction. So law of interaction na kay action tsaka na kay reaction. Ug nganong hilupad maning airplane class, tungod sa iyang wings by Bernoulli's principle, tungod sa difference sa pressure. So we will talk about that in your fluid subject. So nagi kay gitawag nga lifting force. Of course class, applying the third law of motion nga law of interaction, kada motion nagig kay reaction. So ang opposite ani class is your weight. Of course ang airplane nato nam ginay weight. So kaning duha class, the lifting force and the weight is equal but opposite lang sila in direction. So that's the third law of motion class. For every action there is an equal but opposite in direction. So the next type of force is the gravitational force. So this is part po ni siya sa law of motion nga gi-discovered pod ni again the famous Sir Isaac Newton. Kay Sir Isaac Newton na major ni siya sa sa gravity. So sige siya kuan katong apple di ba iyang tong story katong apple na fall fall from the tree. So iya gining field kaning gravity. So in order to find the gravitational force, Newton states that the gravitational force Fg is directly proportional class sa mass sa duha ka object nga nag-interact. So mass 1 times mass 2 but inversely proportional to the square of their distance. So diba sa atong universe na may tayo mga celestial bodies. Let's say mo ni ang usa ka celestial body mas 1 nabugay usa ka celestial body mas 2. Of course na ginay force, gravitational force na nag-keep sa ilang distance. Kay kung wa sila gravitational force class, it's either mo ngadto sila or magkakuan sila, magkabanggaay, so ma-explode sila. So mo na nganong ang earth kay nag-keep sa atong orbit around the sun because of the gravitational force that is exerted between the sun and our planet earth. And the same thing with other celestial bodies in the universe, stars, suns, nga nag-separate sila with each other because all of them exerts gravitational force with respect to each of the celestial bodies. So in order to determine the gravitational force nga na-exert sa kada kuan, sa kada bodies, so we use this gravitational force. And take note class, the gravitational force is equal to this constant. So nanon tay constant nga ibutang nga G. So G m1 m2 all over r squared. And kaning G class is a constant, and we'll know that here ito pala class ang atong G, or in other words G is equal to 6.67 times 10 raised to the power negative 11 Newton times meter squared per kilogram squared. So mo na tong G class. Kung na may problem nga you are given two bodies with mass 1 and mass 2 separated by the radius r. So ang atong gravity ani, or the gravitational force is equal to this. So just remember this formula class. So nasabtan na class? Are you still following? Okay, mo-clarify lang ko ninyo kanang na may klase inig ka 11. Oh, 10:30. Okay, 10:30. So I think let's finish by 10:15 lang siguro, okay ra?
So sa inyo sa ato subject so
okay, so let's jump to the normal and friction force. So for the normal and friction force class, so I think you already know the normal force. The normal force, di ba? Normal force is a force that acts perpendicular to our surface. So normal force is, or this normal force can be used in order to solve our frictional force. So for our frictional force class, again, in this figure, naatay applied force class. So applied force. And diba, as what I have told you earlier, that the frictional force is a force that acts opposite to our applied force. So muna siya class, muna siya ang atong frictional force. And for our frictional force class, we have two types. The first one is the
Kining
static
topic is
frictional force. So static
air fuel ratio.
frictional force.
Butang. Air
So for this class,
fuel
mo
ratio.
gitawag siya static frictional force because this is a
Determine
frictional
the
force that
gravimetric
you should overcome
analysis
before
of the
nimo
products of the
ma-move ang object.
combustion of acetylene
So
with
mo siya
200%
kani nga frictional
stoichiometric
force
air.
class gahit kani siya nga naman
So
di ba
determine
lisod ba
kuno
ya
ang gravimetric.
magpa-start og move
So
sa
from
usa
the
ka
word
object
gravimetric,
if
unsa
ingo pa
may
lang siya
inyo
i-move
nahunahan?
gahit kay na pero mas
Gravimetric
easier nimo
analysis.
i-move ang object nga naka-move na siya daan.
So
So
gravimetric
that's
means
why ang
by
static
weight,
frictional force mas dako
by
iya value.
weight,
So in order to solve for static
or
frictional
in
force
kilograms.
class, so we
Kaya
have
naman po yung
here,
times nga ang pangyan
let's
niya kay
say,
volumetric.
for
So
a
ang volumetric,
horizontal nga object, so na object nga
volumetric
rest horizontally,
is by moles.
let's say it has
By
mass,
moles.
of course, na-exert na siya
By moles.
weight, so ang yung weight is mass
Yeah.
times gravity.
And also the products
And then of course we have normal force here, acts perpendicular with our horizontal horizontal plane. Then let's say nag-apply tawag force dire, so F applied.
200%
Again class, please remember nga ang imong frictional force is opposite resisting force, opposite to your applied force. So you have here
equals
F
100%.
and then since class ang atong condition ani is just about to move,
or
so
another
about to
example,
move
example na kay
mo pala pag-move
150%
na to. So
na
we use
theoretical
the
error, equal
static
na siya sa
coefficient of friction.
50%
Kay ang coefficient of
X
friction
X
yung ato
na,
naibuan
so
class sa
na.
last kay
Sige,
just
sa ato
mu
yung
lang.
problem.
Actually for friction class we have
So,
two. We have
Ano
mu
na?
s and mu k, but this time since static pa lang ta, let's denote this as mu s, or the static coefficient
limit ko
of
record.
friction. So static coefficient of friction mu s. And in order to solve that, again class, our friction is just equal to this coefficient
Wait,
times
wait,
the
wait,
normal
wait.
force. So mara gini class ang friction, the coefficient of friction and the normal force. But ang pinaka-quadri class kay unsa ang atong normal force, sir? So remember, if we sum up the forces on the vertical direction, we now have the value of the normal force, which is equal
Sige,
ra
sabayin
siya
ta.
sa atong weight. So
So,
our normal
una
force
is what
is equal
ang
to
combustion equation
mass
sa
times gravity or
acetylene.
weight.
So, ang acetylene,
So therefore, this
so,
is now our
unfortunately, wala
formula
i-mention diri
for our
sa problem,
static
acetylene.
friction
Pero,
on a horizontal direction. So
ang
horizontal man siya.
acetylene is
Sir, how about kung
C2H2?
naka-incline ka, sir? Of course. Namin yung mga basis class nga
so, manang
magbira ka
chemical
og mga
formula sa
objects nga naka-incline. So for
So, this is what
for an
ang
inclined plane
combustion
class,
acetylene.
second
So,
naka-incline ta.
C2H2
Theta. So
plus
natin theta class. Then we have here an object.
XO2, wala
So again, we have
ibang
weight.
oxygen. Pero mo ni standard nga
So we have
equation.
weight here.
Plus
And then we have here an imaginary
3.76
rectangle that will
X
resolve our weight.
N2.
So this one class mo
May
siya gitawag
products.
nga
So, na
weight,
kay carbon, so,
sine of
yung
theta.
product na ay carbon dioxide
Theta man siya diri class.
plus
Then this is
kay
angle
hydrogen,
45.
so napod kay
And
water
this one right
dioxide.
here is also weight
Plus,
cosine
copy
theta.
ang nitrogen nga wala
So
sila
cosine
kaya
theta na siya class cosine. And then of course atong normal force
N2.
class always perpendicular gina siya sa atong surface ha.
Wala kahibaw kung
So,
pila ang
normal
atong
force.
carbon dioxide.
Then
Ang,
let's say this is our
wala kahibaw pila ang atong water.
frictional force kasi di ba ang kung
So,
kani siya
kaya pa nga
class
natay duha ka
kung nga ni ang orientation sa imong object, of course mudalin as mo siya pababa. So mo na siya ang atong direction sa atong motion.
Common sense to,
So
kung
direction
dapat
sa atong
ang
motion,
CO2
mo na siya ang
parang
motion.
equal ang carbon.
So kung padung among motion nadto,
So, ato na
ang atong
ibig
frictionary
sabihin.
class is opposite. So therefore ang friction natin is
So, muna
going
tayo,
upward. So this
ibaw na
is
ta kung pila
FF.
ka buok CO2. Tungod
So
sa
para
carbon
ma-solve na
dioxide
to
sa
class
CO2.
ang relationship
So,
between
parang
our
ganun.
angle of inclination and the coefficient
So,
of
ato
friction.
ang
So ato siya
H2O.
i-resolve.
So natay
So, here,
H2
class,
nga rin.
We know
Natay
that
H2O. So,
FF,
since 2 nga rin,
so F of
ito na
F
may daan, so
is
dapat
equal
1
to
H2O,
the
kaya
mu
para
s.
balance.
Kay static man ta, kay about to move pa lang ha. We're just about to move.
So 1
Multiplied
H2O.
by
So,
the normal force.
Unya, ato
And
i-
since
solve
ang normal
X,
force
ang
class
plan
is
X. So check
kani
na
siya nga
siya,
forces that acts
So
perpendicular.
natay O2 nga rin,
So
O2.
ang equivalent niya
Unya,
class
sa
is
product
this
side,
kasi diba summation
sa
of
CO2 natay,
forces
ibig sabihin
vertical
order.
is equal to 0. Unsa yung mga vertical
1 ka
force?
O2.
I mean vertical
Ito
force
rin
with respect to
natay
this,
0.5
with respect to the
na O.
inclination. Of
O2.
course, we have normal
Kay O
force,
man ni siya,
which
niya
is equal to
O2 man ang ato kuan
the
diri. So,
weight
ako lang
cosine of theta.
i-divide
Kaya diba, more man
para
yung
O2
opposite
gyapon.
cosine of
So,
theta.
0.5
So
O2.
therefore, we can say
Kay
that mu
usa man
s
ka O. So,
is
equal sa
equal to
0.5
weight
O2.
cosine theta.
So, pala may total
Sana
ano niya?
weight cosine theta. And then,
1 plus
here
0.5
class,
equals
we can say that
1.5.
ang kanisyang kuan, I mean, kuan de class, FF is nu s, and we can also say that
Sorry.
FS class,
2 man
kaning
dahil siya.
FF class, equal po ni siya
2
sa
O2 kanyang dito ito diri.
FF is
2
equal
O2
po
then
sa
0.5.
force nga
So,
padung
2
pod
plus
nga di class.
0.5
Ang unsa
equals
man ang force nga
2.5.
padung ari? Of course,
O2.
our weight sine of theta.
So,
So
therefore,
therefore,
sa value sa ato
this
x,
also equal to the weight
2.5.
sine of theta, which is also equal to
Sumata,
this.
sa ato si O2
Equal
natay
po siya
2
sa
ka
ating butang
O2.
ari. So you have mu s
Kaya natay
weight cosine of
natay
theta.
adding
And since on both equations natay weight, so
sa
makancel
ato
ni siya.
H2O
What's
natay
left
1
is
ka O,
sine theta
which is
is
equal
equals
to
to
0.5 ka O2.
mu s cosine of theta.
2 plus
And
0.5
since we are
equals
just
0.5
aftering with
O2.
mu
natay
s,
value
so
sa
we
x,
have
which
mu
is
s,
2.5.
divide natin ng
So,
cosine
pwede natin
theta,
i-plug in. Ato po i-plug in array
divide na to cosine
sa
theta.
nitrogen.
So we have mu s is equals to sine theta all over cosine theta.
3.76
And
times
what is this?
2.5.
This is just equal to tangent of
Yeah,
theta.
dili gyapon,
Therefore, ang
gyapon.
ating static of friction for a horizontal plane is just equal to the tangent of our
2.5.
inclination. So, mara siya class. Mara na inyo
So,
i-remember class sa
ako
mga
i-rewrite
problems.
apat kaayo.
So, medyo hapit na ang 15
So,
hapit na ang
C2H2
uh,
plus
10-15. So,
2.5
let's jump sa
O2
second type
plus
of friction.
3.76
Namin ko tayo
times
gitawag
2.5
kinetic
N2
friction. So,
equal to
kinetic
CO2
friction.
plus
So,
H2O
on-side differencer sa
plus
static of
3.76
kinetic friction. Static class,
times
naghunong.
2.5
So, stationary.
N2. So,
Or
muna
about to
motion
move.
equation.
How about for kinetic friction, sir?
For
It
Kuan
is
niya,
used to analyze
theoretical.
moving objects. So, nagdagan na. Kay bisag
or
nagdagan imong
stoichiometric
object class, let's
or
say, natay object,
geometric.
imo na siyang gi-applied og force, nagdagan niya.
So meaning wala
So,
wala
nagdagan na ni.
include ari ang excess na tong air.
So, meaning
Not
class,
excess air.
you still have a friction here nga ma-experience nimo. Siyempre, naman ginang friction, di minamuha, bisag nagliho, bisag nag-steady ka na pa, or about to move, or nag-move na ka, nagyapon na ang imong friction. So, again, friction is opposite, class opposite sa imong motion gida, FF. And kahit na nagdagan ka, nagyapon kay weight. Then you have a normal force that exerted upwards. Now again, always note that the normal force is equals to mu, the coefficient of friction times the normal force. But here class, di na nato magamit ang static force. Nga naman, nag-move naman siya. So, unsa man natong gamiton? Of course, the kinetic friction. So, we have here mu k. So, mu k times the normal force. And what is our normal force? That is equal to mu k times our weight. So, this equation only be applied for moving objects. So, for moving objects na siya klasa. And to summarize this class, our value for our mu k class, mu k is always less than 2 mu s. Always remember this class. Gamay ang atong kinetic friction, atong coefficient of kinetic friction kaysa sa static friction. Why? Again, because ang static friction is mo na siya ang friction nga imo i-overcome para ma-move nimo ang object. So, mas lisod ba ya pagpadagan sa object kaysa sa pagpadagan sa object nga nagdagan na. Kaya mas dali ra to nimo birahon. So, next, I think di na madano kay na may klase ang uban. So, let's just end our discussion here sa kanang frictional force, and next time lang ang spring force and other forces.